Hello everyone, welcome to part 2 of making Pong and Godot. In part 1, we did some initial project setup and created our paddles. We created our paddles manually and through code. One big problem we still have is our paddle is stuck in one place. Not very fun and would make for a rather boring game of Pong. In this video, we'll be giving our paddles some movement and adding a second paddle to play against. If you didn't watch the first video, don't worry, I'll post a download link in the description with the starting files for this one. Let's get started. Back in our paddle script, I first want to note I moved the paddle color to be a constant. Otherwise, everything else is the same. Now, we have this process function down here, where we can update our paddle's position. However, we'll want to change this to be physics process. Otherwise, we may see some jittering or inconsistent collision behavior. Let's get rid of this comment here as well. Now, our paddle can only move in two directions, up and down. To detect which direction to move our paddle in, we will need to take some user input. To take user input, we need to define some user actions. We can do this by going into project settings, input map, and adding some actions. And we can add a new action by clicking on add new action, and I'll call this player 1 up, click on add. Then we'll need to bind our action to some sort of input key. If we click on the plus icon next to our action that we just added, and we press an input on our keyboard, we'll go with W, then press OK. It will bind the W key to the player 1 up action. Let's create another one called player 1 down, add, and bind it to the S key. We can close this. Back in our script, we can get the direction to move our paddle in by using our newly created inputs. We can use these inputs by calling input.getAxis, and then we'll put in our player 1 up movement, and then we'll do our player 1 down. We can set this to a variable, which we'll call direction, which is of type float. And we need to move the paddle at a fixed speed based on our direction. We'll set the paddle's position dot y value plus equal to our direction times some speed, which we'll create up here. We'll call it const speed float equals, and we'll say 400. I'll come back down and we'll multiply this by speed. And to make the movement consistent across different frame rates, we'll also need to multiply by delta. Now, if we run our project, we can move our paddle. But if we keep moving our paddle in one direction, it will go off the screen. We can fix this by clamping our paddle's position to the bounds of our screen. Go back to our paddle script again. Define a new vector2 variable. We'll say var, and we'll call it screen size, which is of type vector2. And in the ready function, we'll set screen size equal to get viewport rect dot size. Then, after calculating our paddle's new Y position, we'll want to clamp it to the screen space. We can do this by setting position equals position dot clamp, and we'll clamp it to a minimum value of vector2 dot 0. And then the maximum value will be a vector2 consisting of our screen size dot x, and then our screen size dot y. And we'll also want to make sure to adjust for our paddle size as well. So we'll say screen size dot y minus height. Run our scene again, and this time the paddle will stay on the screen. Awesome. Currently, we only have one paddle, but in Pong, there are two. Let's add another. Make sure we are in our main scene with the root node selected, and we'll drag a new paddle scene instance onto our main scene. And remember, our paddles look all messed up in the editor because we were messing around with them in the previous video to showcase that we overwrite their values through code. So we don't need to concern ourselves with what it looks like here in the editor. Let's rename our paddles to player 1 and player 2. But when we run the scene, we have a problem where one player's input controls both paddles. We need to separate the input logic so different inputs control different paddles. In fact, our paddle should not care at all about player inputs. Our paddle really only cares about moving in a certain direction. We should have some sort of input handler that then tells our paddle which direction to move in. Our paddle can then take that direction and move however it likes. I'll attach a script to the main node. We'll call it main.gd and we'll save it in the main folder. Again, we'll replace our process function with physics process and set our input logic here. I recommend pausing the video and trying this yourself. To get you started, you'll want to define two variables at the top of our main script for our paddles, then update the paddle script by writing a new function, then call that function in the main script's physics process. Okay, let's start by defining variables for our paddles with onReady. So we'll say at onReady var player1. And I like to statically type my variables. So to do so, we'll need to go into our paddle script and give this a class name, which we'll just say class name paddle. Go back into main, make this of type paddle equals to our player1 node. Do the same for player2 at onReady var player2 of type paddle player2. Let's copy over our input detection from our paddle script. So I'll go on here, copy this, and paste it in the physics process function in our main script. And we'll want some way to update our player1 paddle to move in this direction. It'd be nice if we could just call something simple like player1.update and pass in our direction and delta. Then our paddle can handle the rest. So let's do that. Player1.update, and we'll pass in direction and delta. We'll need to go back into our paddle script and implement this new update function. So we'll define the function. We'll say func update, and we said it would take a direction float and a delta float. And this will be return type void. Now we can take updating the position in our physics process, copy it in, and we can delete our physics process function now. Then run our scene, and our paddle moves. Cool. But our second paddle still doesn't. We'll need to define and handle inputs for the second paddle the exact same way we did for our first paddle. Try it on your own, and I'll speed this up and do it quickly. So all I did was just add new input mappings for player 2. I bound them to the up and down arrow keys respectfully. And also I renamed these variables to say player 1 direction, player 2 direction, and we just call player2.update like we did for player 1. And the paddles move independently. Awesome. Let's finish this video by moving our paddles into their proper positions on the edges of the screen. Let's also turn off the collision shapes in the debug editor, since we don't need them anymore. Again, in the main script, create a variable for the screen size, say var screen size equals get viewport rect dot size. Then we'll assign our paddle positions according to the screen size, plus some offset spacing from the edge. We'll make our offset spacing from the edge, call it const paddle spacing from edge of type float equals, and when I messed around with the values, I thought 100 was a pretty good amount of spacing. Now we'll take this paddle spacing from the edge and our screen size to calculate our paddle positions. So we'll say player1.position equals vector 2, and this is going to be on the left side of the screen. So it would start at 0 plus paddle spacing from edge. And then we can also just get rid of the plus 0. And for the y value, we'll want to add screen size dot y divided by 2. So that way it's in the middle of our screen. This won't be exactly in the middle of our screen since we aren't accounting for the height of the paddle, but it's close enough and it doesn't really matter. And this is an easier formula to read, so we're going to go with that. Set our player 2 position as well. So say player2.position equals vector 2. And this is on the right side of the screen. So I want to take our screen size.x and want to subtract our paddle spacing from the edge And we'll also set this to the middle of our screen. Run the game and perfect. Our paddles are in their proper positions at the edges of the screen. Unless we resize the window, then everything gets all messed up. This can be easily fixed by going back into project settings, click on General, Display Window, go down to where it says Stretch, and we'll change the mode to Viewport. We'll select to keep the aspect ratio as well. Run our game again, and our paddle position will scale with our screen size. Perfect. And that should do it for this video. The question for the day is, who is your favorite video game character to control and why? Mine is Mario from Super Mario Galaxy. I love all his little jumps and honestly just spent a long time in the hub area playing with his movement. Thank you all so much for watching. I'll see you in the next video.